So should hopefully be able to see my screen. Everyone see that?
Yes.
Okay,
yeah,
perfect. Right, so welcome everyone to this webinar on SSP and DThermX. I'll just get that. So just a brief introduction to ourselves. So my name's Peter Morrison. I'm the business engineer with SWEP. I've been here for 2 years now. Largely my job is to usually work with the design team, try and find the right solutions to the problems you have. I don't really work with the sales team. I'm not really in sales, but I do some small quotes. If you're looking for small quantities, I can help you with that. However, once we found what you want and you wanted big quantities, that's when I would pass you over to the RSM, Adam. Adam's on the call. Do you want to introduce yourself, Adam?
yeah, sure. Thanks, Peter. So, hi everyone. Adam Raymond from SWEP. I'm the regional sales manager. I've been with SWEP 5 years. So, at the moment, I'm covering the full country, UK and Ireland. And as Peter said, if it's more of a commercial matter, pricing terms, things like this, business cases, then that would be more my area of expertise. But between Peter and I, we share the load with quotes and designs and things. So yeah, welcome to the webinar, and I hope you all enjoy it and hopefully learn something new that you didn't know before.
Right, thanks, Adam. So we'll send this PowerPoint over. So it's got our contact details if you want to get in touch with us. A few things just to be aware of. We do CPDs. We are SIBSE certified. We can do CPDs for anyone here who's a consultant. We are more than happy to travel. We can do it just one of us, both of us on Teams at your office. We are flexible. So if it's something you're interested in, then please do reach out to one of us. I'm going to be largely just quickly going through a lot of the software. I will say there's a few things where I'll say this is more covered in the CPD, but I won't go into depth for them. Also, if anyone here wants to do like a one-on-one meeting with me, if there's something you want to go a bit more in depth with that I haven't really covered in this, please do reach out to me. I'm more than happy to do that. And also, if anyone here is going to be using the software for the first time and thinks I'm not 100% sure how confident I am this is the right selection, again, send me the selections you've made. I'll have a look over it, and I'll let you know if that's the best option or if if you should go for something else. I will show you how to download the data sheets as well, so you can send them to me if you want to do that. So on slide 3 here, this is how to access the softwares. So SSPG8, so it's a downloadable version. It basically needs to be downloaded and installed into your system. Personally, I do prefer this one. It is, in my opinion, better. If you're not able to or you're not allowed for whatever reason, if your IT department won't let you, DThermX is something that is available online. It is just as good, but I say personally, I prefer the SSP. When I'm doing the demonstration, I will be using SSP. I will try as much as I can to say the differences between that and DThermX. So if I say with SSP, this is how you do this, in DThermX, you would do this. I'll try and sort of talk you through it. But anyway, that's basically that's the introduction out of the way. So let's get on with the software. So this is this SSP. I'll largely be using single phase calculations just to talk you through the processes, because a lot of stuff I'll be talking through here, it will apply to evaporator and condensers, but I'll go a little bit more in depth with them once I've sort of gone through the single phase. So when you open the single phase, this is what you'd see. So the first thing to be aware of is the stock filter here. So the filter here, if this is ticked, it means everything you're going to see will be stuff that's available from our stock rooms in the Central European warehouse in Germany. Obviously these things are a lot faster to be delivered, but they are very specific what you can buy. If you're looking for something that's more tailored to your needs, then obviously untick that, but be aware that this would be subject to minimum order quantities, depending on the size of the unit. So small units, they're, I believe, 10 minimum orders. If it's bigger units, then it could be just one. I wouldn't expect you to know what sizes are what. So obviously, if you did want that, reach out to one of us. We'll tell you if there is an MOQ for that. So then once you've sort of decided whether you want filter or if you want production items, then you would obviously decide what the fluid you want. Now we have got a huge list here. It's been a little bit slow. So this is the huge amount of fluids. With any luck, if there's a certain special fluid you need, it will be on the system. If it isn't, if for any reason you find it is, there might be something very similar, but if it's something very specific you need and it's not there, what you would do is you'd go to fluid editor just here. If you're using DThermX, there should be a little picture of what looks like a hammer on the same sort of position here. And we'd hover over that, it would then show fluid editor in there. So to add a brand new fluid, give it a name, reference. Reference I usually just fill in the same as the fluid. Approved by your name, it's fine. And then what you need to do is you need to put the temperature, density, specific heat capacity, conductivity, and either dynamic viscosity, or if you prefer it, you can click here and change to kinematic viscosity. You need these details at varying temperatures. I have got a Excel sheet that I've used as an example, just to give you a rough idea what it should look like. So this is one I've just made up. The sort of numbers are roughly correct. I've just made them very linear. So as you see, the specific heat capacity I've changed in factors of 10. In reality, the change would be very random, very similar, but very. So you could drop 10, then it could be like 12, then 11, then 10 again. It's not going to be this linear, just to make you aware. Another thing to be conscious of is the units. A lot of times, so if you require this number, you can usually get it from the supplier of that fluid, but just be warned, they might give it in a unit that's not what we have. So if you look here, you can change the units to something different, but just be careful of that. I think recently I did have one where I had the specific heat capacity in joules kilogram per Kelvin. I accidentally put it in as kilojoules. So I think I was out by a factor of 1,000, which when I ran calculations, the temperature differences were absolutely crazy. So just be careful of that if that's something you need to do. So once you've got the fluids in, you have to decide, is it countercurrent or co-current? Something we go into more depth in our CPD, but 99.9% of that is countercurrent, unless it's a reversible heat pump. Then you might want to do a co-current, but I think I've done in 2 years. I think I've done maybe one calculation with a co-current, so fairly good chance that you're not going to have to worry about this. After this, you are looking at the types of heat exchangers. So most of the time, B types are what you would look at, especially with single phase calculations. E types are something I think Adam might know more. They're predominantly boilers, are they? E types. Sorry. So yeah, the FI types and PI types, and then V types, P types, F types. So most of these other units are predominantly used as evaporators. I'll go into this in more detail once we jump onto that. But most of the time, you'd be using B types. You wouldn't need to worry about changing this. You do have the option as well if you go here to look at specific units. If you wanted something of a specific size, or you just have to say, oh, okay, I want something like this unit, you can select that instead. So once you've done all that, then you start putting in your inputs. So a lot of you will probably be familiar with the equation Q equals m dot Cp delta T. So the Q is the heat loads, m dot's the flow rate, Cp is something that's already known by the system, and delta T would be the change in temperature. the system needs, so basically what you need to do is put enough information in that the system can then calculate something. So in this case, it knows the heat load, it knows the temperature, change of temperature, it can then work out the flow rate. If you try and put any flow rate in here, it's just going to freeze up and just will not let you calculate. Even if that flow rate is exactly correct, even if you calculate it and it says, right, the flow rate would be this, it's going to assume you're wrong. So ideally what you need is one piece of information missing from each side. So you could take out a temperature and put in a flow rate if you wanted. It would work that way. Or you can do three pieces of information on one side. So you could have a flow rate here and no heat loads. Because then what it would do it to use this side to calculate the heat loads. And then once it's got the heat load, it can calculate the flow rate. You can also remove one temperature and run it that way. But be warned, if you do that, it will take quite a while because effectively it's looking at every possibility, saying, okay, if it's this temperature, what would be a good unit? If it's this, what would be a good unit? It will take a bit of time to do that. And if your computer's struggling a bit, it could potentially cause this to crash. So try to avoid this if you can. And also just be aware you can change the units as well on the flow rates and stuff on literally anything. If your unit, if your specs are in a different unit, you can change that. And also, so with the pressure drop, whatever you set the pressure drop at, it'll basically give you the biggest unit it can, or the unit that's going to be at the closest to this, but it will go above by about 5%. So just be wary of that. If the unit is too, if the unit's too big, if it's a bit over surface, you can reduce the size of the units, but that would increase the pressure drop. So what the system will do is say, okay, this unit's at its limit for pressure drop. That's the unit you want, but be wary, it is oversurfaced, which I'll come on to in a little bit. If you want to add some oversurface into it, so you say, I want it at least 10% oversurfaced, you can put it in here. We would not recommend that though. If a lot of people see it as a safety factor, we don't. It's just going to cause problems. So we would recommend you don't use that if you can. So once you've got all the information here, I'll maybe cut this down to 200. This, let me say 600 this, say 1040. I've still got the filter on. So anything that comes up is going to be stock products. Okay, so then once you've got this, you'll have this data sheet that shows you loads of information. You can also go at the bottom here. So this is the technical data. You can look at dimensional data, which shows how big the units are according to the width, height, length. And you can also look at totals, which shows how heavy the units would be and how much water they can hold, how big the connections, the ports would be, where the connection would be attached. One thing you can do as well, if there's certain specs you really want to have a look at, if you right click here, go to column options. So this is a list of every single spec you would look at. If you click on one, it then gets added to the list here. And if you click here, it moves it up. So it'd be a case of whatever's on the bottom would be on the right here. The higher up you bring it, the closer to the left it would be. So you'd be instinctively seeing those first. So personally, these are the ones I quite like, the ones I often have a look at. PF, just to make you aware, PF is price factor. So it's sort of saying roughly how much the unit would cost. So 100 usually means that's the cheapest option. 136 would be, this option would be 36% more expensive than the cheapest option, just as a rough guide. But so yeah, so once you have this, once you have this data sheet, what you can do is you can do technical printout. So this is to get this data on PDF file if you want to send it to me to have a look at or send it to a customer. In this case, you just save. It would save as a PDF, change the name, save it wherever you want, send it an email. With DThermX, you download it. So just be wary, it would go into your download folder as opposed to saving it to a folder you wish to have it in. Alternatively as well, you can do product selector. So in this case, it's looking, because it's a stock product, it's looking at units that are in stock. So a green thing here would say it is in stock. Be careful of that though, because sometimes this does take a little bit of time to catch up to our stock level. So it is saying it is in stock. It might be it was and it's ran out, or sometimes it says it's not in stock. It might be that we have replenished it and it just hasn't caught up. So always double check with us if you're buying a stock product, is it actually in stock? I won't go through the whole thing, but yeah, if you go through the next stages, it will allow you to add things like insulation, counter flanges, etc., anything like that you need. One thing I'm going to mention as well, just because we do get asked this quite a lot. So it's saying here you should be in this side here, out here, in cold in here, cold out here. A lot of people will ask, is it possible to move these around? The answer is yes. This is a recommendation, provided that the inlets are diagonally opposite each other, in which case the outs would also be diagonally opposite. You can put it anyway. I mean, you can swap these around. That could be hot in, hot out, cold out, cold in. You can flip them right round, so that's cold in, that's hot in. It doesn't matter. Whatever works for you, whatever is your preference, that is fine with us. As long as it is diagonally opposite, it will be fine. Next. So yes, so one thing, as I said, to notice is the oversurfacing. In this case, it's 9%. Right. So oversurfacing, the best way to explain it is it's some kind of like a very simple speed distance time equation. So the speed would be the flow rate, which you've already preset. The time is the time that the fluids spend or need to spend passing each other to get that temperature difference that you're looking for. And the distance would be the size of the unit. So in this case, it's saying the unit is 9% bigger than it needs to. So the distance is 9% bigger than what you need. Therefore, the time they're passing each other would be 9% longer. So as a result, the temperature change that you need will be slightly higher in reality. To actually determine what that would look like, you can use performance, where you basically say, right, I want to look specifically at the B12 MT. So you can either cross out and search for it, or you can right click, clear all but this. So unless you see a dash, a number and the letter P, the number passes as 1. So if it's dash 2P, it'd be 2 pass, dash 3P, 3 pass, etc. Number of plates is the number after the X, so it's 30 plates. And then what it asks you to do is remove one piece of information. Usually temperature is better. Usually I think a lot of people, for water applications, they prefer the outlet sign 1 to be taken out. And what it'll do, it will say, what does this number need to be to get 0% oversurfacing? So originally I had that at 50, so in reality, you'd be looking at 46.35 to get this thing working absolutely perfectly. The question you would then ask yourself is this good enough? That we can't answer for you. That would completely depend on your application and your needs. So that's how performance here works. Rating is pretty much the same as performance, but instead of getting the right it basically says, I want to use that unit under these conditions, what would it do? So if I put it as, say, 60 here instead of 50 as before, it would say it would be 35% oversurfaced. And so it's the two things. The main thing when you're doing rating is look at the oversurfacing, see how high it is, and then obviously if it's quite high, then consider using performance to get a more accurate readout. Another thing to be aware of is the pressure drops, because with the design is the design is to tell you what is the best unit, and the pressure drop is something that is fixed, set. With this, doesn't matter what you put as pressure drop, it will give you what the pressure drop would be for that unit. So be wary, it could come out very high and it won't really warn you about it. So just have a little glance at it to make sure it's at a level that you're comfortable with. So that, I believe, is pretty much everything when it comes to single phase. So I'll quickly jump over to the evaporator just to quickly talk through this. So with evaporator, so I think most of the things I've talked about already are relevant here. So with the first, obviously, you want to select the correct refrigerant. There's loads of options, but these are loads of all the things we can do. So if you just look for the refrigerant, and obviously whatever you want on site too, which bit off energy back in. As I said before, we do have units that are specific to evaporators. The reason for these ones is these units have what's referred to as a distribution device. So with B types, they don't have a distribution device. There is nothing stopping the fluids from going up. With evaporators, if it's coming in as a liquid, it suddenly becomes gas, the first thing is going to go straight up. It's not going to go through the full length, which is what you really need to get this thing working as you need it. So it'll start going up too soon, and then anything further back, it'll be a lot less gas. That's what's referred to as maldistribution, which is something you want to avoid. These are units that have distribution devices. They're kind of like pipes with holes in them. So it'll get to the first hole, a lot of the gas will try and go up. They'll realize a lot of the gas will realize I can't, goes to the next hole, next hole, next. That forces it to go the full length of the unit to avoid maldistribution. You can use B types, but we recommend it not be more than 30 plates, just to be aware of that. Also, oops, as I said before, there are these units, so the SVHQ, they don't usually pop up instinctively. They are also evaporators, but the reason for those are one thing calculation one number that's very, very important with these is the pressure drop in the distribution device. So here you're getting warnings saying, where is it here? Yeah, it has low pressure drop in the distribution device. We recommend it be at least 1 bar pressure drop. It should be in here. So right here. So here it's considerably less than 1 bar, so it definitely wouldn't be a suitable option. So yeah, what you really need is at least 1 bar in the pressure distribution device, but it has to. We recommend it be less than 30% of the expansion pressure drop. If you're using a thermostatic expansion valve, if it's electric, we recommend it be less than 50%. A lot of times with the S types and Q types, I believe, this should give you sort of higher ones. So if this one's a bit low, these usually should be a bit better. Okay, that's not what I wanted. So yeah, that's the sort of key things to know about evaporators. With calculations, things you need to remember are you need either the inlet or the vapor quality. Either one of them can work. You need to know the evaporation temperature. If you don't know that, you can find it using just get that. You can use it using fluids properties, which shows this would show what you input to get the fluid editor. So if we say R32, right? If we look at the fluid editor, say R32, and you know the pressure, so say you want to do 20 bar, then you'd have the dew temperature here. So that gives you the evaporation temperature. You input that. You then put in how much superheating you want. So superheating is the evaporation temperature is here. We want to add this many degrees of heat to ensure this thing is completely evaporated. System usually recommends you have at least 5K superheating. If you go any lower, it will give you a warning saying it's a bit low, we don't like that. Another little trick as well, just so you're aware, I'll try and bring this up. Will say I do struggle a lot with this on DThermX. But with SSP, what you can do is you can, if you get an error message, you can double click it, and it should actually give you a little bit of information on it. It's on my other screen, so I'll bring it over. So it gives you some information about what that is trying to tell you. It gives you a little bit of an idea to sort of say, right, this is what we're saying. After that, your call. Some of the error messages might be, do not pick this is a bad solution. Some might just be just to let you know, but it's your call after that. So that's pretty much largely what you need to do with the evaporator. Condenser, I don't think there's much else to know. Same as before, condenser temperature, subcooling instead of superheat. I think it is with condensers, it doesn't need a distribution device, so B types are absolutely fine for this. So any type of units or any type of B units, any plate count, absolutely fine. So the last thing I believe I was going to talk about was the multi-calc. So I've got 2 minutes. I'll try and get through this quickly. So with multi-calc, what this does is it allows you to run multiple calculations, ideally where you're just changing one slight factor. So you're probably more looking at rating or performance, because so if you basically say, right, I want to look at certain conditions where I'm changing like the heat load slightly, but I want to know each time what is the best unit, then you would use design. If you had a unit in mind, which is more common, and you find I want to see how this unit performs under certain conditions where I'm changing, say, the heat load or the flow rate just slightly in stages, then you would use the rating. So say we want to look at the B12MT, sorry, plates, say 200 kilowatts, and let so it was from 80 to 50 cents or 10. So you run the calculation, first of all. You've got the unit I showed you earlier. Then you go to export to multi-calc. And then you save this. So I'll put this desktop. So this would save as an Excel. So this is all the information that you need here. What you do is you would change, say you want to bring this down in stages of 10, you go down to 90, down to 80, and then you can just come down like this. And then what you need to do is you do the same for everything here. Everything here. So once you've got all this, you copy and paste all this, you put it back in here. So yeah, copy, put it in here. With DThermX, at this stage, once you've sort of got this information on the Excel, you'd click import. You instead of copy and paste it, you just click a button, it would bring it back in, and then you would calculate it. So what you're looking for, once you've calculated it, what you're looking for is for all these to start showing ticks. Once you've done that, click save and open, and it would show here what it would show here actually what all these numbers would look like. So you can then sort of say, right, is the pressure drop okay? Is it adequately over surfaced? Is it good Reynolds numbers, good shear stress? So Reynolds numbers is about is it turbulent enough, which something again we cover in the CPD. Shear stress is it high enough to make sure that we don't have any calcium attaching to the unit that could block it. So yeah, once you've done that, you have all the information you need in this Excel sheet. It's not necessarily most fundamental. It can be useful if you do need it. I don't use it very often myself, but yes, it could be useful. So I think that's everything from my end. Is there any questions in the chat that go for it?
I've not seen anything come through, Peter. Or actually, something has just popped in. Let's have a look.
So if you've got any questions,
No, it was just my post originally. So
okay. So if there's any questions, we've probably easier to use the chat function or to see if there's anything
there's a
I've not covered.
Q&A and the chat. I mean, either or will get a notification. So here we are. Let's have a look. Someone's just joined. So one's come in, Peter. Can users have a look at the heat transfer correlations SSP is using for its multi-phase calculations, specifically the heat transfer coefficient relations? And can these be user defined? It's a good question.
Yeah.
Can you see that one in the chat?
Yeah.
Yeah.
The heat transfer coefficient.
Perhaps it's within the data.
Yes, I'm thinking. So it'd be here. Heat transfer coefficient, I believe, is this one here.
Yeah.